So boom, now I got to go to this, right? And then I'm here, so I just say I'd like to leave my picture here. All right, before before I deal with ellipses a little bit more and show you what the point of that demonstration. And I guess I can't show students here, but I did do a little demonstration on how an ellipse is done. Forget it. I'm not going to move this thing, but used the piece of string, and talked about foci and all this other stuff. We'll talk about that in a minute. Put this up at the top of your notes, and then talk within your group how to complete the square on that. Now, those that are playing at home, so go ahead and write that down. I'm going to hit freeze on the screen so my students still see this circle equation. And you should know that's a circle equation just by the format of from Monday. Okay, I know it's been a long break, but doesn't matter. Excuses. We got to get back into the swing of things. But back in our calendar for those online and those that are not online, I'm going to flash to this real quick. I'm going to unfreeze. On the calendar, we got nice 2 videos of completing the square from Monday of last week. I'd be smart to watch that, not make excuses. All right, this guy takes a long time, but it's less than 5 minutes, which is not bad. And it really pertains to this one, which we're going to do right now. So I did throw those on Monday. I think I referenced that those were there Monday. Now go ahead and try to complete the square with your friends. And then I'll just leave this video rolling as we do that. We should be doing something every single desk. Okay? Because when I say complete the square, you say take half the middle term and then what? Square it. Oh my gosh. Okay, and then by the way, nobody should be putting a decimal. I yelled at 6 hour. What's 5.5 squared? And I go, no decimals. I told you. That makes it harder. You are gone. Huh? Huh? Both. Yeah, I'm worried about that circle worksheet, if that's complete or not. So I'll get that circle worksheet tomorrow. Okay, so here we go. I've stalled enough. X squared minus 6x. Okay, shh. What's that first blank? 3, 2, 1, go. 9. Did you hear enough people in the room? Because half of -6 is -3. -3 squared is 9. Then this will be a perfect square. By the way, I'm jumping ahead of myself. So I get that -5/4 over there by adding 5/4 to both sides. And then whatever I do to one side, say it. Now I'm going to change that in a minute here. I'm going to change it now. I want a common denominator. So 9 is 36/4. And I told my last hour I cry at night for students that don't understand where I got 36/4 from. I literally cry. Don't complain about cat. Complain about you don't know your numbers. You don't know how to add 2 fractions by getting a common denominator. Anyway, plus y squared plus 11y. Now here we go. How do I complete the square? We take half of the middle term. This is what ticks me off. Students, boy, he's so angry, that don't understand how to take half of 11, which is just 11 halves, not 5.5. Then square it. What's 11 squared? 3, 2, 1, go. 121. What's 2 squared? 4. And then lo and behold, whatever I do to one side, say it. So I have to, and then lo and behold, I have all common denominators on the right. Everything looks great. Then the next thing, the whole point of doing this, it's making another thing that makes me sad. I still have people sitting in here that cannot think about factoring. And we talked about in August, September, October, and November. All right. What multiplies the 9 and adds to -6? -3 and -3. This is x minus 3 times x minus 3, or x minus 3 squared. So again, not knowing how to factor is a major, major problem. And we can't worry about it anymore. We got to move on from you. We have to. It's up to you to get this stuff figured out. It's in your court at this point. Okay, and then what multiplies the 121/4 and adds to 11? 3, 2, 1, go. The number's staring on the page. 3, 2, 1, go. 11 over 2. This is the MA number. 11 halves, of course, multiplies by itself to be what that we just did that. And then 11 halves plus 11 halves is 22 halves, which is 11. So this becomes y plus 11 halves, and then equals, I'm going to go ahead and do a little math here, 3641. Oh, geez, 60, is that 162 fourths? And then all that becomes is 81 halves, which is a mess, but it's okay. This is a circle with a radius of the square root of 81 over 2, whatever that decimal is, and it has a center at 3 comma negative 11 halves. So the video that the other guy, and I don't know if I completed a square a lot. I don't think I did a fractional complete the square personally. All right, but then I put the video of the guy doing it and I told you about it. Okay, now today we are only going to be taking ellipses that are at the origin. So I'm going to have no H and K. It's really no big deal though. So I want to compare an ellipse real quick to a circle. And then here's a circle at the origin. Remember what I told you, a circle at the origin is just x squared plus y squared equals r squared, okay? And then r, you take the square of that number, and that's the radius. Okay, but I'm going to do something. Or I'm going to do this for the purposes of showing you how easy it is to compare a circle to an ellipse. If I decided to divide both sides by r squared, then I would get this equation. And I guess I'll erase this. You could see you could understand that math. I decided to divide by r squared, both sides, to get it equal to 1. And then all that happens is the radius squared value is just underneath both x and y. That's it. It's no big deal. Okay, now I'm going to go right to the equation of ellipse and then go backwards and go back up to these words. And that's why I gave you this so you didn't have to write all this stuff down. Look at this equation. This is telling you that the numbers underneath the x squared and the y squared are different, not the same. Hence, I mean, look at our pictures over there. One's short and wide that I did in class. One's taller and skinnier. So I have different x-axis and y-axis radii. That's the difference between an equation of a circle and an equation of an ellipse. All right? And then in this one, for this particular one, this is the larger radius squared. So this is a short, wider one because you have a bigger x-axis radius. This is a smaller radius squared. So therefore you have a smaller y-axis move up and down. So this equation 100% would look like a picture like this. Now, you're not going to letter this out. A, B, C's, and all this other stuff. C is important, though, and I'll get to that in a minute. So here's what the terms are. So from the center, here is the x-axis radius. Notice it was a squared underneath x squared. So I go a right and a left. That's why it says a comma 0, negative a comma 0. And then the y-axis radius said b squared. That's why I go b up and b down from the center. And then I draw the ellipse, and it's an ellipse. It's not a circle because I have different radii value. So simple. All right. Now, oh, and I forgot. Do you know Earth's orbit's elliptical? Did you know that, right? Do you know what one of the foci are? What's almost in the center of our orbit? The sun. They actually, do you see what I'm doing with my hand? The sun actually wobbles, all right, and it moves a little bit. But the sun is actually in the focal position for Earth's elliptical orbit, which is almost circular, by the way, but it is considered elliptical. Now, notice the foci. These are the pins. That's where I put the pins for the rope demonstration with a string and the marker. All right, that's where the foci belong. Notice they label it one focus, so 2. Okay, and then this one, this is the smaller, and this is the larger. I'm just going to put smaller and larger. So yes, technically, you got to memorize that A is the larger of the two when we talk about letters. But really, just do your radii. Do your radii, and it's going to be the simplest thing to graph these things. Okay? And then look at this. See? See? I go up A and down A, and that's a bigger y-axis radius. I go smaller right and left. Oh, and then notice, where are the foci now? That's my second example. The foci are on what's called the major axis. They're on the longer of the two. So that's why I want to go back up to here, and you got to have that memorized. All right, all these things. An ellipse, focus of the ellipse. That's the foci, which I showed you as the tax. Major axis. What do you think the major axis is? The bigger axis or the smaller one? 3, 2, 1, go. Bigger. Minor is smaller. Vertices and covertices. That's we'll talk about that in a minute. And then focal radii. That's just the focus and how I move, and the center is going to be 0, 0. And then all this stuff is what I demonstrated on the board, basically. They don't mention minor axis there, but they should. Oh, they do. Down there in the highlighted thing there. So major axis is right, left. That's where the focus or foci are. Major axis up and down. Notice that's where the foci are. That was my second example. Okay. Might want to highlight that. Okay. That's why I like this thing. So you don't have to write all this stuff down. It's kind of makes it look easy. And then notice some of the things that they have down there. Major axis length, minor axis length. Don't get all up in arms about that. Here's the big thing. And then I added eccentricity here. And I'll write something else about this. But this is the big key. How do I find the foci? It's from that magical formula that looks like the Pythagorean theorem, except it has a minus sign. Here's why it has to have a minus sign. C has to be smaller than A, which I think is written in the far left over here. C has to be smaller than A because C represents the foci. If this is an elliptical orbit and the sun is one of those two positions, then the Earth would be going around the sun, which is true. If C was larger than A, then this is how you say Earth goes around the sun. Is this how it works, everyone? No. Okay, so the foci must be smaller than A. What I'm trying to hammer down is that's why we have a minus sign there, because you're going to have this memorized. When we get to hyperbolas, there's a different formula. I'll just tell you hyperbolas plus, right? And you can't flip a coin and switch these two. The foci must be inside the ellipse. So here, a better way of saying it is, look, the C value must be smaller than the A value. C, A, C, A. So C squared equals A squared minus B squared. Okay? All right, eccentricity. Now I could talk about that with the drawings that I had up there. It does come from whatever C is divided by whatever A is. You have to write this. I didn't type that in yours. And then one more thing. When E is closer to 1, then it will never be 1 or over 1. But the closer it is to 1, it is more elliptical in nature. That's my first drawing. Look at the tacks and how far they were away from each other. Actually, where the tacks were almost where the x-axis radius is. So when I take those two numbers and divide, I almost get 1. And then my second drawing, I put the tacks closer together. You would expect an eccentricity that's closer to the 0 side. That means you would have a more circular. That's why I asked you those questions when I was doing the two drawings. You at home, if you wanted to, you could probably Google drawing an ellipse with a string. I bet you would come up right away, someone demonstrating exactly what I did here. No doubt about it. Oh, let me hide that. We don't need that there. Okay, all a mouthful. Now we're actually going to do it. We're just going to graph and find all the things. Now you need your own piece of paper, so take a minute to get your own. I just wanted to give you one little like cheat sheets of the ellipses, the main idea, and then we can go from there. Okay, and as you're getting your notes out, where do ellipses happen? They happen all over in the real world. I got a nice, from Mr. Cernowski, real world video about where conic sections happen in the real world. And if anyone's listening, obviously it's space orbits, but also it's in architecture. It's a really cool application with elliptical ceilings that will be shared in the video. It's all over the place. All right. Okay, so you got to graph the equation, identify vertices and covertices and foci, and then also eccentricity. We'll get eccentricity written down here. Okay, so of course you get words. You got words. You got vocab. You gotta follow along with here. Okay. All right. Sorry if I can't get this any larger here, but do the best we can here. Yep, that's it. Okay, so identify vertices, covertices, foci, and eccentricity. I'll rewrite that again. I'll label it out as I write. Okay, so you should understand right away how this is not a circle. A circle would look like this: x squared plus y squared maybe equals one of these two numbers. Let's say 144. Got that paper ripped out? Good. All right, what's the square root of 144, everyone? 3, 2, 1, go. 12. So it would go 12 right, 12 left, 12 up, 12 down. That's not what this has. This has an x-axis radius of 12. This has a y-axis radius of 8. So to graph this, I go on a coordinate plane. You know what? I'm going to pick a weird decision. I'm going to go by fours. 4, 8, 12. 12 comma 0, 4, just for time purposes. And I should mark that as going by fours. What a weird decision. Because 8 goes by fours as well. So 4, 8. And then you can see yet again, like my first drawing, this is a short, wide one. Of course, having a coordinate plane would be really nice, but we don't have that. We're just making a sketch. And that's what it said for me to do. And then guess what? You can already find the vertices. And then this is why I love, conic sections. A, they can be easy. B, you got to remember your grade school. You got to make this coordinate. So to go right, left 12, it's plus minus 12 comma 0. To go up, down for the covertices, remember, covertices are the shorter of the two radii. So you just got to label it appropriately. That's 0 comma plus or minus 8. And you can do that. You can write it as plus minus instead of listing two of them. This isn't rocket science. You would get a lot of points for just having this so far. I don't know how people can mess this up, but they do. And it does make me sad. And now for foci. Here's what you got to do for foci. Work off to the side maybe. So the foci are found by c squared equals a squared minus b squared. All right? So that is 144 minus 64, which is 80. Okay, so slow that down for a second. 144 minus 64, which is 80, and then you root it. Now, 80, listen, is 8 times 10, but 10 is 2 times 5. Let me drag that 2 over to 8 and get 16. 16 times 5. What's the square root of 16? 3, 2, 1, go. 4. Okay, that's my mental math. Now, okay, but going backwards, if I had to graph this, what is the square root of 80? It's close to the square root of 81, which is 9. So nice. The square root of 80 is 8 points, like close to 9, 8.9 probably. So literally it should be like right there and right there inside the ellipse. There's the c squared equals a squared minus b squared. Very important. So the foci then can be written like this. Knowing the foci must be on the longer of the two axes. This is the major axis. So I'm going to color that. That's the major axis. That's why the foci had to be there. And think about that. If I actually accidentally did the focus along the minor axis, they'd be outside of the ellipse. Square root of 80 is larger than 8. Okay, so anyway, you must write this as a coordinate, and it's plus minus, and I'm going to go back to that exact answer. Just wanted a rough estimate to know where exactly it landed. Not exactly, but where it landed. And an eccentricity, I'd have to get a calculator to get this decimal, but it's C, 4 root 5, over A, which is 12. You certainly couldn't leave that. You should reduce. 4 over 12 is 1 over 3, root 5 over 3. Oh, square root of 4 is 2. 2/3 is 0.6 repeating. I bet you square root of 5 over 3 is like close to 0.7, maybe. Maybe it's 0.6 something, maybe 0.7. Closer to the 1 side. And this is a little bit ovular compared to circular. Okay, I'll only do one more of these. Yet again, one more reason why this should stick out that this is an ellipse. Because a circle would be this. Don't write that. Write the one on the left. But you got to understand a circle would be x squared plus y squared equals 9 with one radius, 3, 3 up, 3 down, 3 right, 3 left. This will be different because of that 9x squared. So we're not graphing that. I just wanted to make a point. All right. And then what do I have to do in order to get those radii? What do I got to do about that 9? Divide. Divide to get it in proper format so I can properly see my x-axis radius and my y-axis radius. And I am going to write that 1 so I know. So I know there's at least something there. People think 0 and then they don't graph anything. Okay, real quick on this one, graphing it, super simple. 1, -1, comma 0. The x-axis radius is the square root of 1. The y-axis radius is the square root of 9. 1, 2, 3. 1, 2, 3. So there we go. Vertices, in this case, are 0, comma, plus or minus 3. Do not switch these. Vertices, I guess I could put this. Those are the endpoints of the major axis. This is what your book says. Endpoints of major axis. That's what the vertices are. And I guess I'll write this because someone was confused last hour and I don't know where they lost stuff. The endpoints of the minor axis is what the book says. That's the covertices. Coverts. And those are plus or minus 1, comma 0. All right, so just some other terms that the book used so that you can make sense out of this. All right, and then foci, we got to do a little, I didn't finish my drawing. And you can see that my eccentricity is going to be bigger in this one. It's going to be closer to 1. This is way more ovular when I draw this. Okay, the foci, I actually have to do my math, which is c squared equals a squared minus b squared. That gets my c value to be less than my a value. 9 minus 1 is 8. Root it. 8 is 2 root 2. Now, the square root of 8 is close to the square root of 9, which is 3. So it's really tight right here. These are really close to each other. Okay, and that's the point of those having to be on the major axis. That's the second drawing that I did. So the foci are, we'll write the whole thing. 0, comma, plus or minus 2 root 2. Go back to that exact answer, but do understand the square root of 8 is close to the square root of 9. And then eccentricity, well, now that I got that 2 root 2, I can put 2 root 2 over 3. And then if you type that on your calculator, I bet you do get 0.9. Square root of 8 over the square root of 9. So 2 root 2 over 3. I bet you that's closer to 1 by far. Okay, enough of these. I'm not going to do another one of those. You'd have to divide, and then you get some big numbers here. Now it's these kind of questions. So take a minute to write this down. Okay, this is the well, you don't get these often. You had them with circles. They gave you some information. You had to come up with an equation. So yeah, you definitely did have those. But this is a little different. First time you're running into these. Really hope my volume's working. Sometimes we get volume issues if I hit the wrong button. Okay, so I will say something on this one tomorrow. These are going to be a little bit more complicated. So you'd be a silly fool not to make a drawing. I'm just going to tell you that right now. This one's an easy one. This one tells you what the radii are already. You're already, like this one, when you do just a little bit of homework, this is going to be like one of the simplest questions you can run into. The book does not use these terms, though. It does use vertex for major axis endpoints. It doesn't use this term. So remember, this is major axis endpoint, major, larger. This is minor axis endpoint, smaller. Okay? The book will say endpoint of a major axis is, endpoint of a minor axis is. They also do use the term vertice or vertex, still major axis endpoint. Okay, well, it's silly. If I actually draw this out, it's simple. If I went -10, here's -10, 0, -10, well, then I'd also have to go 10 up, and then there's my y-axis moves. Because 0, -10, well, it has to be 0, +10 because they're telling me I'm centered at 0, 0. So they're literally telling me my y-axis radius. And then a covertex is 6, 0. Let's just pretend that's 6, and that's -6. Well, that would be that, and I've been given the x-axis radius. So I don't need to draw it. I need the equation. Here's the equation format. And then everyone, or a few, tell me what number goes underneath x squared. Let's see if this works out. 3, 2, 1, go. 36. How many people said 36? Raise your hand. Nice. It's easy. The x-axis radius squared. Now everyone should be able to get the next one right. What's the y-axis number underneath there? 3, 2, 1, go. Hundo, 10 squared. 100 goes underneath there, and guess what? It's over. That's why this is the easiest question, because these two things are the radii. All right? Tomorrow it's going to get more challenging when we're not centered at 0, 0. You're definitely going to want to make a picture. Okay? Two more of these because these tend to be more of a challenge. And don't worry about those numbers. I pulled this from an Algebra 2 book. We're going to do almost exactly the same as my Math 2 honors students are doing in this right now. They're right in the middle of this chapter. They did ellipses before break. Okay, we do have a problem. So it gives us the vertex and a focus. And I didn't really give this letters. You got to get these letters down. So remember what a vertex means? That's a major axis point. That's on the major axis. That's what that means. It's the longer of the two radii. Notice it goes 4, 0, which is right. I shouldn't have to go, which way is that, class? You're a bunch of seniors and juniors. All right. So I have a question. What letter is this? Is that letter A, B, or C? 3, 2, 1, go. Yeah, you're going to have to know that A is this letter. You're going to have to know A is the major axis letter. Because then you really have to know what letter is this. 3, 2, focus. 3, 2, 1, go. C. Because you could go ahead and get part of this done. You know you're filling this out, and then really what you're just trying to find is these radii values. That's what you're trying to fill in. Those are the empty spots. So what goes underneath x squared? 3, 2, 1, go. Not 4. 16. 4 squared. So I don't know how purposeful it is to draw this. It really isn't right now. Tomorrow it will be. But literally they're telling you the x-axis radius when they say a vertex is at 4, 0 and the center's at 0, 0. That's how everyone got that. But now how do I get the other radius? Now fumble. I got to use my formula. C squared equals A squared minus B squared, and it's got to be memorized. What we doing over there? Okay, so C squared is √7 squared, which is 7. We're over here. And then A squared is 16. So it's not 16 squared. A squared is already 16. I was given C, which is √7. √7 squared is 7. Okay. All right, and then notice this did go right as well, so that's where the focus should be, on the major axis. All right, well, I subtract and I get a negative, but a negative equals a negative means a positive equals a positive. Okay, now here's the question, because I get all three answers. What goes underneath y squared? Is it 3? Is it 9? Or is it 9 squared, which is 81? Which number goes underneath y squared? 3, 2, 1, go. 9. You are right. I will get all three different answers from goofballs. Okay? This is the radius squared. This is the radius squared, b squared. So 9 goes there. Not 3, not 81. Right, Pablo? Looks like you're sleeping back there. Are you okay? Okay, then I'll do this one just for our last one, and then we'll be done a little bit early. So, yeah, sorry, fumble. I'm a little off, after the 3 days off here. What is the covertex? Is it A, B, or C? 3, 2, 1, go. B is correct. So this is our B value. Covertex is minor axis. Covertex means minor. Your book doesn't say covertex. All right, and then what's focus 0, 6? What is that? A, B, or C? We already had that the last one at C. Okay, so what you should at least be able to do is say this: x squared plus y squared equals 1. And then I have to square this. Negative 3 root 5 squared is 9 times 5, which is 45. Where does 45 go under? X squared or y squared? Look at that point again. 3, 2, 1, go. You're gone. X squared, because covertex, this went left 3 root 5. That is an x-axis move. That is an x-axis radius. And then also look at the focus. The focus goes up and down. The major axis is up and down. I need to find my y squared, and that's going to be a bigger number. So one more time, maybe we should. And by the way, what's the square root of 45? Square root of 36 is 6. So 3 root 5 to the left is approximately negative 6 point something to the left. That is the x-axis radius. Negative 3 root 5 comma 0. So that is an x-axis radius squared that goes underneath there. So yes, everyone said y squared. That was interesting. All right. And then how do I find y squared? Again, it's the magic formula. So today is just getting our basics down, getting this formula used in your homework so you get it memorized. Then we'll get a little bit more complicated tomorrow. C squared, 6 squared is 36. We already got A squared is 45. I did that math already. And then you'll get another negative. Did that end up being 9? Nice. Okay. Oh, right. I'm a maroon, which actually changes everything, which I would have caught this because I would add a smaller y-axis radius. Nice call. I'm finding A squared. This is where B squared goes. But I again would have caught my error. I'm not kidding. I would have caught my error because the y squared would have been less than the x squared, and that can't happen. The y squared is supposed to have the major axis because the foci are on the major axis. So nice. Okay, here we go. Do I put 9 underneath y squared? Do I put 81 or do I put 81 squared? Which one do I put? 3, 2, 1, go. It's just 81. It's the b squared, or actually the a squared value in this case. Then notice this is larger. And notice the foci went up and down. That's why the major axis has to be on the y-axis. All right? And that's the kind of stuff we got to get figured out here for today. All right, I'm done. Chillax on our first day back.